IBM has been working on quantum computing since the 70s.
That's true.
Even today, there's very little that's intuitive about quantum computing. If Jordan knows 1%, I think she's exaggerating there, but 1.01% is what I know. So if I gave you this stage for 2 minutes, and you had to explain to us what quantum computing is all about, what do we need to know to understand quantum computing?
Yeah, I would start with the foundational principles of what makes a quantum computer, potentially powerful. And there's 3 key elements, right? I mean, a quantum computer fundamentally exploits the principles of quantum physics to operate very different in the computational realm compared to a classical computer. And the first principle is the principle of superposition. And one way to understand it is imagine that you have a coin. And in the classical world, we have our zeros and ones, and we flip the coin, it's in one of the 2 states. But if we were spinning the coin, we would see that, in some sense, it's in a superposition of heads and tails, right? So that's principle number 1.
I'm going to stop you for 1 second there. I think we're supposed to see something on the screens, and we're not, so if anybody can bring that up in the back. Or not, I'll let you talk, but there should be something up. At some point you will see something up there.
Yeah, so that's the first principle. Then the second one is something called entanglement, which is a beautiful understanding of the nature of our physical world. And now, to just give you an analogy, imagine you have 2 coins, right? So each one can be in the superposition of heads and tails. But now we have an interesting situation that if they are entangled, which we get to do when we have quantum bits instead of coins, then we can have these correlations, these perfect correlations at the time of measurement. So if we did a particular measurement, if one was measured heads, the other one will be measured heads too. And if one was tails, the other one will be measured tails as well. Now that is something that you do not see in the classical world, right? So the type of measurement that can happen when these or qubits are entangled is fundamentally different than what you can see classical. And the third principle is the principle of interference. So once we have our qubits or quantum bits in this superposition and entangled state, we get to do an operation that we cannot do classically, which is to, in a computational sense, which is to interfere. And interference is the idea that you can sort of cumulatively add amplitudes so that the peaks go up, or you can cancel. If you have a positive and negative amplitude of the same amount, you can cancel that. And that's why, when we see it on waves or in noise canceling headphones, we have that idea. So those 3 principles are the kernel of how you go about building a quantum computer and what gives it its power. And I'll share in a little bit, perhaps, how an algorithm works and what's the power.
Did everybody get that? Did you mostly learn how to cheat in Vegas with coins?
That's right.
Right.
If nothing else, if you
have
quantum coins, you can.
Quantum coins will let you win in Vegas.